we're looking at production theory and cost theory. So in production theory, we will discuss the production function, which represents the relationship that exists between the factors of production, which we call the inputs, and the goods and services, which we call the output. These ones are produced by a firm or an economy. And generally, the production function shows a relationship between output in terms of labor and capital. So in this general formula, L stands for labor, and K stands for capital. The reward for labor is rent. The reward for labor is a wage, and the reward for capital is rent. The production function can take different linear forms. Some can form a quadratic form, other a complex form, depending on the specific industry we're dealing in. We also look at production in the short run. So production in the short run simply refers to the process when at least one input is fixed, which is usually capital, and only one input is varied, which is usually labor. So this is what happens in the short run. So we'll delve into that as well, but just to quickly guide you, short run is observed as follows. When the short run occurs, one input is fixed, and that input is usually what? And one input is varied, and that is usually labor. So the firm in the short run has a capacity which is limited by a fixed input, which means that it cannot adjust its production levels as easily as in the long run. In the short run, firms usually face fixed costs that do not change with production. They also experience variable costs that will change with the level of production, primarily labor costs. So if we're dealing with a short run production, typically we are looking at a production function in terms of what? Labor and capital. But labor is what? Varied. Capital is fixed. So you can have maybe land, which is a hectare. We will just vary the labor units, like the number of laborers. Okay. So we go to the long run. What happens in the long run? In the long run, production theory states the following: that where a time frame is given, all inputs, labor and capital, can be varied or adjusted according to the firm's requirements. So you can increase capacity of land and machinery. You can also increase capacity of laborers. So firms here are more flexible in the long run to optimize production processes, to expanding in production and reducing costs. In the long run, firms will make decisions about the scale of production, which will lead to maximization. So let's go to the basics of production. So I said output is equal to labor and capital. Output is equal to labor and capital. Now, output is illustrated by what are called isoquants. So this function can have a power, alpha, and beta there. So if you have 0.5 and here 0.5, so when alpha and beta are equal to 1, this means that we have what? Constant retention scale. Sometimes we can have 0.5 and here 0.7. You can see alpha and beta here are greater than 1. These are called increasing returns to scale. We also have a situation where we have 0.5 and 0.3. So this is where our alpha and beta is less than 1. So these are called decreasing returns to scale. You can see in the powers, so their sum is determining what type of returns they are. Now, what are returns to scale? And how do they help us understand the concept of production? So the concept of returns to scale refers to the changes in the scale or size of production, how they affect the firm and the production purpose. Returns to scale will explore the relationship in the increase of output, usually labor and capital, resulting to changes in output. So there are 3 categories that we're going to look at: increasing returns to scale, constant returns to scale, and decreasing returns to scale. I repeat, what are returns to scale and what is the concept of returns to scale? The concept refers to how the changes in the scale of output, which is Q, may result due to the effect of the changes in the inputs of labor and capital. So how do we explain increasing the returns to scale and what happens there? So increasing returns to scale exists when the following happens. Number 1, a firm that experiences increasing returns to scale occurs when production process experiences increasing returns. It means that all inputs, labor and capital, are increased in proportion. The output will increase relatively faster. So graphically, I said the curves that join points that offer the same output are called what? Isopoints. So here, if we have 10Q, here we have 20Q, here we have 40Q. It's doubling. So these are called increasing returns to scale. This is where if you're increasing by 1 factor, this situation usually occurs when we have specialization and efficiency and cost-saving measures. So production is doubling or multiplying. 10, 20, so here it's times 2. It's increasing times 2. So production is efficient. This is called increasing returns to scale. We also have a scenario where we're almost breaking even, where we are considering constant returns to scale, which is proportional to the increase. If a firm doubles labor and capital, output will also double. If it maintains a constant ratio, output will also be constant. So this is called constant returns to scale. Graphically, it may look like this. We are moving from 10, 20, 30, we're increasing by what? A constant rate. So this is called constant returns to scale. Production is efficient, but it does not really lift the potential. So it is just increasing at a constant scale. Of course, the worst of this is the last part, which is called the decreasing returns to scale. This purely is as a result of operational inefficiencies that an organization may incur. So decreasing returns to scale usually will occur when all inputs are increased proportionally, then the output is less than the proportion of the increase. So this could be epitomized by the following isopoints. So here you have 10Q, you have 20Q, you have 25. So here there's a 10, here there's a 5, so it's decreasing. 35 difference. Maybe the next one could be 3 difference from 25 to what? 28. So it's increasing at a decreasing rate. So it is increasing at a diminishing rate. So this situation can result when factors are experiencing operational inefficiencies. So we now go to understanding a few calculations under production. Like I said, the total output is given by TP. The total product of labor, we divide it by the labor units or the average product of labor. Anything divided by labor is called average. Change in total product of labor over change in labor units is called the marginal product of labor. The marginal product of labor, when you multiply it by the price, is called the marginal revenue product of labor. The marginal product of labor, if it's more than the wage, we can call this optimum production. Optimal production. So the wage is also called the marginal resource cost. Are we together so far? Based on these formulas, an examiner will bring in the following: 10, 24, 36, 28, 25. How do we find the average product of labor? According to the formula, it's the total product of labor over labor units. So 1 into 10, we get a 10. 2 into 12, we get 2 into 24, we get a 12. 3 into 36, we get a what? 12. 4 into 28, we get a 7. 5 into 25, we get a 5. Imagine the product of labor. Difference between the total product and the labor units. 10 minus dash over 0 minus dash is what? Dash. 24 minus 10 is 14. 2 minus 1 is 1. So we divide 1 into 14, we get 14. 36 minus 24. What do we get? And 3 minus 2 is 1. Here the difference is what? 6 plus 6 is 12. 12. So 1 into 12, we get a 12 there. And you subtract here again. 28 minus 36. What do we get? 8, negative 8. 4 minus 3 is 1. So 1, negative 8 is negative 8. 25 minus 28 is what? Minus 3. 5 minus 4 is 1. 1 into minus 3 is minus 3. All right. Suppose we have a price of 10 kwacha throughout. The marginal revenue product will be what? Multiplying the price times the marginal product. So this by that, 1/4. This by that, 120. This by that, negative 8. This by that, negative 8. Then if your wage, which is the marginal resource cost, maybe it's 120 throughout, 120 throughout, 120 throughout. You'll be asked now to calculate So to calculate the number of laborers that are optimal, we need to look at the point where margin revenue product is equal to the wage. At this point where they're equal, 120 is equal to 120. What is the wage? 3. So 3 laborers who maximize production at 120. Okay, so the laborers are what? 3. The laborers are 3. So we're just trying to fulfill the formula that is in there. Are we together? Any questions so far? So also, generally, you'll be given a question to say we have 10 laborers. The average product of labor for these 10 laborers is what? 1,000. So this means that the total product of labor for these 10 laborers is simply the number of laborers and the average of all the 10. We're going to get 10 times 1,000. We get 10,000. So we want to employ a new worker. This new worker is bringing additional, whatever is additional is called marginal product. Additional units of 900. So meaning we're now going to have how many laborers? 11. The total product would be 10,000 plus the 900. The total is now 10,900. Now, if we employ this new laborer, what becomes our new average product for the 11 laborers? The formula for total product. The average product is when you divide the total product over the number of laborers. 10,900 divided by 11. What we get? 990.09. This is our new average. Now, if the market price is 2 kwacha per unit, this means that the margin revenue product, this additional units that this guy is bringing, is worth how much? 2 kwacha times 900. So meaning the net worth of these 900 units is 1,800 kwacha. That's the value of what he's bringing. So we can only employ this guy if he's asking for this amount or below. At 2,000, we can't employ because he's an economical. At 1.5, we can employ because we're going to get a marginal benefit of 300. At 1.8, we can also employ, but this is at par. It's only expatriates that don't make a balanced equation. You discover that they're bringing in less than they are being paid. Are we together at this point? Okay. So we can proceed. If there are no questions, we'll go to the exam paper from last year, where we'll be asked to fill in a table. So if there are no questions, we can proceed. Let's consider question number 3. But before we go there, I also need to make mention to say that there are what we call stages of production. These stages are very important because they give us a cycle within which production undergoes. So we have 3 stages of production. Stage 1, stage 2, and stage 3. These stages of production are also known as the law of variable proportions, or the short-run production function. They help us describe how the total output changes as one variable, which is usually labor, is varied, while keeping other variables like technology and capital constant. We know that this is in the short run. So these stages will help us explain the relationship that there is between input and output levels within an organization in a given time frame. So as you can see, we have stage 1 there. So stage 1 is the initial stage. You can see as more labor inputs are added to the fixed capital and technology, the total output is increasing at an increasing rate. So total product, the total output, the TP, is increasing. So you can see the TP is there, increasing at a rapid rate. What else can you see in there? You can also see the marginal product of the variable input, meaning that the marginal product is also increasing. As you add an additional unit, the marginal product is also contributing significantly to the total output. So here, marginal product is also increasing. This is the marginal product. It's increasing rapidly. It's what is adding to this. And we also have the average product. What is happening in the average product? Average product also is increasing. So factors that are contributing to increasing returns to scale in this level might be better specialization, improved efficiency, is effective utilization of fixed resources. Here, firms benefit from hiring every additional worker they bring in. So it leads to higher overall production. And when we go to the second stage, which is stage 2, it's also called the diminishing returns to scale. In the diminishing returns to scale here, as more units of one variable is added beyond a certain level, we can see that the total output continues to increase, but at a diminishing rate. So you can see the total output is still increasing, but at a diminishing rate. It's not as steep as it is, so it's increasing. Okay. What is happening to the marginal product? It is decreasing as we add any additional unit. Marginal product is decreasing. So this one is now going down. Okay. What else is happening? So this stage is also associated with limited resource constraints, such as limited space, efficiency, and firms here would carefully consider to trade off between additional labor and marginal costs of hiring, as the cost per unit may rise. So we also have the last stage, which we call the negative returns to scale, or negative marginal returns. In this final stage, as you can see, adding an additional unit of labor will cause a total decline in the total output. So total decline of total output here, the output is declining. It's going down. Output is only increasing in first and second stage. Average product is declining, but the marginal product is actually negative. So these are the 3 stages that you need to acquaint yourself with. So you need to explain the 3 stages of production for exam purposes. And these are what I've tried to summarize for you here. Okay. First stage is called increasing return to scale. It's an initial stage where we're adding a variable input like labor, leaving capital or fixed, as well as technology. Here is high marginal product and high total product. And also average product is high. Second stage, total product continues to increase. Marginal product is decreasing. Then slanting is average product. In stage 3, total product is going down, marginal product is negative, average product is also slanting. So these are the 3 stages that you need to acquaint yourselves with. Are we together? So now we go to the exam setup. How do questions on production come? So this was our paper. First part was multiple choice. Second part, true or false. Then we have question 5, which has to do with what? Production. For the purpose of this, there are stages 1, 2, and what? And 3. So we are asked for 15 marks to explain and fill in the table. We explain what is happening. So here the marginal product of labor, we're dividing. This one is a dash 72 minus this. We get a figure there. 123 minus that, the figure there. Average product of labor divided total product over labor units. Then the stages, you need to illustrate what is happening here. Marginal product, is it increasing? Average product, is it increasing? Total product, what is happening? At what point is it decreasing? So the 15 marks, I'll need them explained based on what I have just taught you. I'll need this work. Please follow through everything I've explained. So this is 15 marks. It's not only about filling in, you also need to explain the 3 stages of production. Stage 1, stage 2, stage 3. Preferably, you can even show a graph. All my students live above par. They get to illustrate the happenings. Stage 1, the marginal product is positive. Total product is increasing. These 2 are increasing. Stage 2, total product is reaching its maximum, its peak. And the marginal product is exactly 0. It's ending at exactly 0. Stage 3, our total product of labor begins to fall, whereas the marginal product of labor is negative. So this is what is giving you 15 marks. So you need to explain it annexed to the table you have filled in. Are we together? I hope this is elaborate. Thank you so much for your time and have a good day.